To give you a small introduction about Richard, Richard is a senior developer advocate at AWS, who's mainly focusing on developer tools. Richard, thank you very much for joining us today, and it's over to you.
Sorry, I was still muted. Cool, thanks. Yep, I'm gonna share my screen. I did promise Ramesh that I would share like a sneak peek into something that I was working on before we get started. So before I hop into the CI/CD best practices, I would like to share this. So has anyone here used AWS Cloud 9? It's like our integrated development environment. It's a IDE in the cloud. So previously, it was quite a hassle if you wanted to take the IDE that we gave you and kind of like customize it in some way. And the reason for this is that kind of under the hood, when you ask for the IDE, it will create an EC2 instance for you, so you can tell what size instance you want, whether it's a very small one or a very powerful one, based on your needs. And then we would set that up for you and we give you the IDE. But if you wanted to like install some new version of Python or TypeScript or Java on there, you would have to kind of run some scripts and do that on your own after it was set up. And the process to do that was kind of involved. You'd have to stop the instance after it was started, create the role, create an instance profile, attach instance profile to the instance, restart the instance, wait for the instance to register in Systems Manager, then run the command and wait for the command to finish. So last week we launched a new feature that was originally meant to strictly be a security feature. We call it the No Ingress Cloud 9 IDE. And what this did is this allowed us to run the IDE in a VPC with no connections in or out, so that you can have it completely isolated and machine is only communicates via SSM. But because Cloud9 had set this up so that it already communicated with SSM, it did all the instance profile and the role and SSM registration stuff for us. So now when you have a Cloud9 environment, there's some tweaking you have to do on the policy to give it a couple more fairly narrow permissions. And then you can just do like here I'm just creating a file as like a test, but you can use SSM's run command from like a CloudFormation custom resource, and you can just like send it a command so that you know that every time you start up a Cloud9 environment, you'll always like have the specific software be configured in a very specific way. And this is what I was working on. It's almost ready to launch. I have it on a GitHub gist that I'll post in the chat as soon as I'm done presenting. But I think it's one of these things where we made a very specific security improvement, and the result of this was that it actually made the developer experience much better as a side effect. So I was super excited about that. I was going to share it, and then I told Ramesh I would save it and I wouldn't tell anyone about it until the user group gets first peek at this. Okay, so now I'll go back to CI/CD best practices, the actual reason I'm here today. And if anyone has any questions, feel free to you can just unmute and comment in Zoom, and I'll try to answer your questions. I'd like for this to be fairly interactive. If I just sit here and talk about CI/CD for 40 minutes, everybody will fall asleep, and then I'll be very sad. So Ramesh did a great job in introducing me, so I don't have to kind of introduce myself again. So today we're going to cover just the foundations of CI/CD, an introduction, just to make sure everybody's on the same page. We're all talking about the same thing. There's a lot of very nebulous terms, like where does continuous integration stop and where does continuous delivery start? So we're just going to lay out kind of like how we think about the difference between these, just so that as we talk about this, we're all kind of talking about the same things. And then I'll focus on CI/CD for modern applications. And there's a pretty broad definition of what constitutes a quote-unquote modern application. And we're going to go over like kind of what are the benefits of these modern applications. Now I understand that not every shop or every company has the luxury of building like brand new development from the ground up, and they can just start with a modern application. There is a very detailed and involved process to go from kind of this like legacy on-premise monolithic web server that's running kind of like in a storage closet somewhere and migrating that to like kind of an ideal-ish modern application. So we'll discuss kind of some of the benefits there, and then I'll go over kind of how to do continuous integration on AWS, and then how to do continuous delivery. I have a lot of slides, so I'm going to go through them very quickly. I'll also make the slides available afterwards, and Ramesh has my contact information. He can share it in the chat if he'd like, my Amazon email address. That if you have any questions, feel free to just email me, and I can connect you with the right people. So we'll start with the foundations. Right. So at a very high level, you've got source, which is where you store your code, build, which is you can build it to make sure that it actually compiles. So if you're running something like Java or TypeScript or C# or C++, since these are kind of statically typed and compiled languages, you need to build them to make sure they work. You also need to test the application. So you might just because it builds doesn't mean it's actually correct. So you need to run some kind of unit test. And then you have your production stage, which defines where your customers are. And there's other stages in there. I just kind of lump them all into test because all they're really doing is getting you ready for your production environment. So in your source stage, I mean, this is where you check in either your .java, your .py, .js files, the actual source code for your application. Typically, you would make a change depending on how your company handles merging code. If you're a very small shop with only a couple people, you might have the ability to just kind of commit code back to the main branch without any kind of a review. If you're in a larger, more distributed team, usually you'll do something like a pull request or a patch. If you're very familiar with the way the Linux distribution handles source review, but there's some kind of a peer review once you get into a larger organization. I'd say generally more than 10 people or so, you're going to want to do more than 10 developers, you're going to want some kind of peer review. And it isn't meant for someone to kind of go over your code and say you did this wrong and you did this right. Part of it's just that people that you work with have an understanding of what changes are happening, so that if they're planning something else, they can kind of keep that in mind. If they're trying to do a load test or they're trying to debug something, it helps everybody kind of stay on the same page. Right? And then you've got your build stage. So the build stage could be a bit spread out. This could you would build it locally. You do this kind of if you do Java C locally, or if you're compiling something in C++ or Python. Python doesn't really build, right? It just kind of it runs or not. But you run the PyTest locally. You do some kind of local tests, which typically conduct just your unit test, which tests your smallest fundamental components. This is where you'd run style checkers to make sure you're using tabs or spaces appropriately. You could create the Docker image from, if you're part of your application is a Docker image, just to make sure that locally, at the very minimum, it works on my machine. That is necessary but not sufficient for a build step. This happens both on your developer machine typically, as well as in your release pipeline. Normally you would check it in. It would be on the main branch. If you say, okay, now is the time to do a release, it would also rerun the unit test just to enforce that the unit tests were run and they were passing, so that you're not releasing untested code. And then there are several types of testing you can do. So the easiest one is unit tests you do locally, but you also want to do in some kind of a build system, which we'll talk about later. And then there's load testing, UI testing, security testing, performance testing. Integration testing is a broad category. You can integrate with other parts of your application that maybe you don't have direct control over. You can integrate with external products, like calling other AWS services or calling other third-party APIs. These are generally things you wouldn't do in your local build environment. I say in general, there are times when you would want to do this, but there's other times when you wouldn't. Let's say it's calling a third-party API and you might be rate limited on that. You don't want all of your developers hitting this vendor API all the time. Maybe your build per interaction, and you're just trying to keep the price lean on this. So in your delivery pipeline, you would have some kind of a heavier weight integration testing that is trying to test the whole system end to end. And then finally, we have production, which when you deploy it to production environments, there's this gap in between the two here. There's a lot of stuff in there that describes the gap in between test and production in this graphic, because you've got you'll deploy it to a staging environment, and then you'll do some tests on it. You'll deploy it to a pre-production environment, do some tests on it, and then maybe only deploy it to part of your production environment to see how it performs before you roll it out. You generally don't want to just throw the whole thing into production once it passes the tests and just assume that it's going to work. And we'll go over some of these deployment strategies as we go through this session. So typically, continuous integration is it's the left half of this, the first couple. Some people will be very specific and they'll say, well, continuous delivery also includes continuous integration, right? Because you can't deliver something unless you've integrated it. I feel like that's a little bit pedantic. It's a little too focused on what, like, technical terms. Generally, people consider like the integration part, and then just assume that continuous delivery includes integration. But generally, CD is focused on your test and deployment. And then there's a new term that's coming around called continuous deployment, which kind of covers the whole delivery process. I think that calling it CI/CD, people generally know what you're talking about. It's not worth focusing on those. Why are these flashing? Sorry. It's showing me like 3 versions of this in like the presenter mode. I'm just trying to figure out which one is shown to you all. So do you have a question, Manoj? No? Okay. So here are like some of the services that we have that cover these. I'm going to quickly introduce them, and then we'll go over them in detail. So the first one is Code Commit. This is a Git-like version control system. So you can use it with the Git client that comes with your machine or that you already have installed on your laptop or your desktop. That you can do Git push, clone, any kind of Git commands. And then there is a console version of it so that you can visually see diffs between files and approve pull requests and create pull requests. So this is our managed Git offering. Next, we have CodeBuild. CodeBuild is like super versatile. I mean, the high-level introduction is that it's just a managed build environment. It's kind of powered by Docker containers, and you can say, okay, here's the specification for how to do a build. Please go do this. And you only pay for like the minutes that you use it. So if you use it for 5 minutes, you only have to pay for 5 minutes. You don't have to purchase an instance or any hardware for an entire month or a quarter. You only pay for what you use. And it also like scales out and back in automatically because it's fully managed. So if you need to do every night, 10,000 builds, it can go from 0 instances running to 10,000 very quickly, and then scale back down when it's done. So again, you only pay for exactly what you use and how much you use it, and then it scales back down. So there's no recurring costs associated with using it. And CodeBuild also has like several third-party integrations that allow you to do like testing, so that interacts with Sneak, which does security scanning. Interacts with like Jenkins if you wanted to farm out some Jenkins jobs. There's several of these like third-party tools that integrate very well with CodeBuild that support your local and unit testing. And then finally, we have CodeDeploy, which actually puts your application like onto the host. So if you're running an application like on an EC2 instance or on an instance like in an on-premise data center, you can use CodeDeploy to manage picking which instances get updated, updating those instances, monitoring them during the deployment to make sure everything's going smoothly, and optionally rolling them back if the deployment doesn't go as smoothly. We see over to the right that there's X-Ray and CloudWatch. These are like monitoring and observability tools. X-Ray gives you like a traceability, so you can see how long a request takes to get through all parts of your application. And then CloudWatch gives you, the CloudWatch logs, the CloudWatch events, give you some insight into kind of what's happening inside of the system. And then all of this is stitched together with Code Pipeline, which gives you a single view of your source, your build, your deploy, your monitoring applications. So you can see, okay, I was trying to do this deployment and it's stuck at this stage, and then go in and debug that if something happened. And then we have this service called CodeStar, which gives you a good like first pass at getting started with these. It gives you code commit, code build, code deploy, code pipeline, all set up, configured, and running. And you can extend it as you need. And if you want to just quickly get started and deploy your first application, like CodeStar is great for that. There are a few edge cases around how do I do some very like niche or very specific things with it that might not be covered. And in those cases, you'd have to, I call it like escape hatch out or break out, and manually change either code build or code deploy. So CodeStar is there. I think it's a great getting started tool. It helps people start with CI/CD. I think if you're really trying to do some power user level CI/CD stuff, some of the value proposition of that kind of falls off. But it's still good. It's valuable and it has a place. I wouldn't lean on it too heavily all the time. So we're about to start the next section. Are there any questions so far? Is there anything I either spoke about too quickly or you wanted me to go into more detail on? I can let you know if we're able to do that. Okay. I'll assume no news is good news. So these are approaches to modern application development. And there's like 6 kind of key points that you want to do, or that modern application does for you. And these are accelerating delivery of new high quality services, simplifies your event management, it reduces the impact of code changes, it has automated operations, it gives you insight across resources, and protects customers and their business. And I know what you're thinking. You're like, oh, wow, that's a lot of really great things. Like, how do you do that? And this is kind of the parts that are in purple here tell you, like, show you kind of how a modern application provides some of these benefits. So, for example, accelerate. I'm not going to reread all of these again because we're going to go through them, but we see that for accelerating new delivery, like this is done through CI/CD. If your integration delivery process is completely automated, you don't have to worry about someone being tired and not wanting to run a test. Like, it's just completely automated. It runs and the application's delivered. And if you're confident that your tests are testing the right things and they're catching the right bugs and they're preventing failures from getting out, you can create changes more quickly and be confident that like the good changes will go through and the bad changes will be rejected. And again, I'm not going to read through each of these. I'll make the slides available, but we are going to walk through them individually. So the first one is how you create high quality services with CI/CD. And we'll get into some of the effects. Deployment frequency when you're using CI/CD increases from weeks or months in between deployments to either days or hours. We see that the time it takes to go from making the first commit or writing the first bit of code to when it's actually in production, or the amount of time that it takes. I believe in this specific example, it was when the work started on it. So this could be project scoping or writing the code to when it was delivered in production. Without CI/CD, if it's a very manual process, if you're not continually integrating and delivering, it could take up to 6 months, sometimes longer, to deliver a change. Whereas with CI/CD, you can have it in 7 days. I think I just tweeted about something last night that a coworker of mine hit this really weird, like, I wouldn't even call it a bug. It was, we were using TypeScript, we were using a library, part of the CDK, and the thing that it created imported a class that wasn't needed. And the static type checker that was used in the build system was failing because it was an unused import, and we're very strict about removing some of these unused things so your code doesn't get sloppy. And I went in, I made a change, or just a one-line change to remove this unused import, and then created a pull request. Within 10 hours, it was already released and in production, and anybody in the world could use it. And this is like the value of CI/CD, is that when I made that first change, it immediately kicked off a build to see if that change actually compiled by itself. Once it was approved by the maintainers, it did another build right before it merged to make sure that once it did merge, the system as a whole would still build. And then once that was done, it actually performed the merge and merge in there. So this way you have a really good idea that any change that gets merged won't break the build. I mean, there still might be bugs. You still need unit tests and some of these other items, deployment canaries and observability, but that a lot of the very easy things will be caught automatically. So you don't need someone spending a lot of brain cells trying to reason about the code and say is this going to break something, if you know that you have tests that are sufficient enough to catch it. I went off on a bit of a tangent there. I apologize. Another one of the effects of CI/CD is this change failure rate. So they measured of all the changes that went out, how many of them resulted in some kind of a breakage that required rolling back the change or quickly issuing a patch. Without CI/CD, it was 40 to 60%. This comes back from the fact that if you're not continuously integrating the code, a lot of the changes that you are making just kind of build up, and you get what are called big bang deployments or big bang integrations, where someone just takes a huge volume of changes and just tries to apply them all at once. And when something breaks, it's really, in the best case, something breaks and it's very obvious something is broken and you can attempt to fix it. Where it gets more subtle is that it breaks in the sense that it doesn't uphold the contract that you have with your users, where an API might return a slightly different value, but doesn't just outright return nothing. And these get very subtle and it's harder to detect. And then when they are detected, it might be too late to roll back. So you might have to quickly make a patch. If you don't have CI/CD, it's very difficult to deploy that, and it robs you a lot of resources of trying to kind of fix these bugs after the fact. Teams that have adopted CI/CD have have seen this drop from 40 to 60% down to 0 to 15%. I question how many people say that they have a 0% change failure rate. I wonder if they just never deploy anything, so that's why it's 0. I mean, it seems a bit suspect. It's from this the 2018 DORA, which is the State of DevOps DevOps Research Agency, I think is what the original term was. I believe they were later acquired, but they still run the survey. And about 50% of software teams who adopt CI/CD end up in this 0 to 15% range. So, as I said, inside of CI/CD, there's continuous integration, continuous deployment. So first we'll cover continuous integration and the AWS services that support this. Before I do this, are there any questions? Like, feel free to ask any question. Like, there are no dumb questions. If a lot of this is very basic and you think I'm going too slow or you want me to cover, feel free to chime in. I'm not going to be mad if you say you need to talk faster or slower. Okay. I'll just assume I'm doing a perfect job and there's no way for me to improve. I'm kidding. So the first step is, what are the goals of continuous integration? Ideally, you'd like this to automatically kick off a new build as soon as your code's checked in. So as soon as someone pushes a commit, you want to start a build to see, like, is that a good commit? If you're like me, like, I'll commit stuff like knowing that it's broken, and I usually commit it to like a development branch or a personal branch, just as a way of like checking it in case I lose my laptop or spill something on it or something happens to my hardware. I know that the code is saved because it's checked into this version control system. There are ways to configure it so that it only builds on certain branches or builds for any branch. But you do want to build and test in this consistent, repeatable environment. There's few things that are worse than when someone like checks in code and then you try to run it and it breaks and they're like, well, it worked on my machine. Like, I don't know what to tell you. Docker gets us a lot of the way towards this with like Docker containers. You can get these repeatable like build environments because CodeBuild uses Docker kind of under the hood to perform some of this. It also gets you very close to this consistent, repeatable environments. That's not to say that people can't take a Docker image and then do some stuff that becomes random or non-deterministic and making API calls out to other systems or doing other stuff that makes it difficult or not be consistent. But it helps get you closer to that than what just building it on a local machine and assuming everybody has the same environment. And the real goal for this is to have some kind of an artifact that's just always ready for deployment. That's like built, tested, and ready to go. It doesn't mean that as soon as something's checked in, it's immediately ready for deployment. There could be a 2-day wait time in terms of it has to go through a lot of automated checks. But at the end of that pipeline, kind of stuff is always coming out. So if you're making changes every day, 2 days later, things are still coming out. That the throughput is what you're concerned with there. And then what you like to do is make the feedback cycle between when you make a change and when you realize that it's broken, if it's broken, to be as small as possible. So you still have that mental context and you can say, oh, I think I know what fixed that. There's a few things that are worse than when you make a change, you check it in, 2 weeks later, someone's like, hey, you made this change a few weeks ago and it doesn't work. And then you're trying to remember what you were thinking 2 weeks ago. It makes it more difficult to debug. So code pipeline is like the first part. This stretches across the entire CI/CD spectrum, and it allows us to do this continuous integration. It's a continuous delivery service for fast, reliable application updates. It has a graphical interface, so you can see the actual release process. So you can say, I know this is in development or test or production or wherever it might be, and then it integrates with other third-party tools. Okay. So some of the supported sources for this. You can pick a branch from code commit. You can say, or from GitHub, so you can say always pull from this GitHub repo on this branch. You can have it sourced from S3, so maybe you build your application somewhere else and you just put like the finished build thing into Code Pipeline. Code Pipeline will pick up that build thing and then deploy it, via S3. It's a specific object in a folder, like in a bucket, and it relies on the versioning of S3 to know, like, what needs to be deployed or not. This slide's a bit old. This isn't now supports ECR. You can use ECR as a source. I should probably reword this. It's a new option. And you pick a Docker tag and it watches that. It looks for updates to the latest, like the hash of that, and it can deploy Docker-based applications based on changes in ECR. Here's some specifics I'm going to quickly skip. So you have some source actions in code pipeline. You also want some like deployment targets. You can deploy to EC2. You can use CodeDeploy if you want to deploy on-prem or on-premise. There's Elastic Beanstalk, HopsWorks, CodeDeploy, ECS, different types of ECS deployments. CloudFormation, you can just do a raw, regular CloudFormation. So if your application is just a bunch of CloudFormation resources, it can manage the CloudFormation deploy for you, updating Lambda functions, updating your Fargate task. And then you have triggers for like kind of what starts your pipeline. So you could have scheduled, a lot of places have like nightly builds, like every night, whatever's the head of the main branch will get pulled in, it'll be built and then staged and tagged as like the nightly build for a specific night. It's usually done for like builds that take 4 or 5 hours to finish. So it starts around midnight, finishes about 4 a.m. When people come to work around 8, 9, 10 a.m. in the morning, like it's done and they can start using it or debug it if the nightly build failed. Also like health events, you can do specific webhooks from like Docker Hub or from other services that they can kind of reach out and poke code pipeline and say, hey, like you need to start doing a pipeline release. Here's some artifacts to use to do that. So the next two parts are like simplifying your environment management with like serverless technologies and reduce the impact of code change in microservice architectures. This isn't saying like you need to make your application entirely serverless, right, to be considered a modern application. You can have a modern application that's running on some kind of hardware, especially if you needed GPU instances or some other capabilities that aren't supported in serverless infrastructure. But there are ways to kind of simplify this management with the serverless technologies. So for example, if you're using Lambda, you could use Lambda to kind of check if have a build succeeded and then do some action based on that. So you don't need a person going in and making these changes. And I describe Lambda as kind of like kind of return. What's that?
Oh no, Richard, I lost your voice for like a few seconds. I hope it's just me.
Oh, okay. I can start that over. Yeah. So the idea is that you can use Lambda as like the glue that kind of holds this stuff together. It can be invoked by a lot of services. You can run just regular Python or Node or Java code in there, and you can have it say, okay, go and check this thing, and if this is true, do this other thing. Just basically whatever kind of code you can write, you can put into Lambda, and this means that you're not running like hardware, like actual servers, like all the time that you have to build and maintain, and then you have to hire an ops team to maintain the servers or debug when the server breaks. So it means that you have to like quote unquote own less stuff, and it kind of stitches these parts together, and all you're really worried about is that business logic that connects the two. So that reduces the operations burden that you might experience, so you can focus more on like building your application, which allows you to build more quickly and deliver more frequently. And then Fargate I describe as kind of like a step up from Lambda. If you need something a bit more than what Lambda offers, Fargate offers like longer execution times or a bit more control over what the host operating system looks like. If you have a specific application that requires that, you can have what I call like step up to like Fargate if Lambda doesn't quite get you there. So the next service is CodeBuild. This is, as I mentioned before, it's this fully managed build service. You don't have any build servers you have to maintain. It spins out these containers, does your build, spins back down again. You only have to pay for the build time that you use, and it's on a by-minute basis. And then you can monitor your builds through CloudWatch events. You can have the logs put into CloudWatch logs. There's a couple of new features with like tests. So if you're running unit tests, you can specific testing features have been released that allow you to see how many of my tests passed or failed, what's my code coverage, and it gives you a better insight into what's the quality of the application that I'm writing. Right? And each build runs in a new Docker container. The Docker and AWS CLI are already installed, so you don't have to worry about installing those and setting up Docker, setting up the CLI. And then we offer several like custom kind of like base images that are good for most customers, but you can also like bring your own Docker image if you need something very specific that you don't want to rebuild each time. So this is an example of a build spec. So CodeBuild uses what's called a build spec. This is the specification for the build. It's got several phases. Build is one of those. There's an install, pre-build, I believe. There's like 5 phases. There's build, there's post-build. So you can break these up. Say, okay, here's all of my install steps. Here's all of my build steps. Post-build, how to kind of clean up the build afterwards. If it goes and sets up some resources, you want to tear them down when you're done. And then you've got this artifact section, which describes what to do with the thing that came out of the build. Sometimes if you want to just use CodeBuild to like run some commands, you can just leave the artifacts blank because you're not really interested in files that come out of it. If you're doing an actual build to release an application, generally you have some either compiled application, a binary, or a Docker image that you want to save. This is where you would do that in the artifact section. Here's an example of like building a Docker container and then pushing it to ECR, all kind of in the build stage. I mean, this is a toy example. It assumes that there's no other dependencies that need to be installed, but it shows like a basic like how to build a Docker image in ECR. So we've covered like how to automatically kick off new builds, build and test code, have this artifact ready, and then close that feedback loop, which kind of rounds out our continuous integration section. So I'll take this opportunity to like stop and wait for a moment. Does anybody have any questions so far? Anything I've covered right? I know I speak fairly quickly, and I try not to talk very fast, but if there's anything that was confusing, feel free to unmute or say anything.
Hi, Richard. Yeah, I have a quick question. I'm not sure if it is covered in the later presentation. The question I have is like, if we want to do performance testing and end-to-end testing, how do we hook up, let's say this, maybe like we are using third-party services and so on. So how do we hook up those services into our pipeline? Let's say after our deployment, we want to run some performance testing and make sure those things are like all the performance needs are criteria are met and so on. Is there like, how do we really do that?
So how that's done typically varies based on the type of testing that you're doing. So for example, let's say you wanted to do load testing, right? Like that's a common performance test that people tend to do. I wouldn't say they do it with every release in general, but it's something people want to do. So you want to do a load test. You want to send a lot of traffic at an application and kind of see how it performs under a lot of stress. And a way that could be done is in your code pipeline. You, depending on your application or how it's configured or how you want to perform the load test, I've seen where people have used. I'm trying to remember. There's an application. I can't remember the name of the application now, so I'll just describe it, and then when the next speaker is talking, I'll go look up what the name of it was. I want to say it's like artillery, serverless artillery, I think is what it's called. And it runs in a Lambda function or a set of Lambda functions, and you give it an endpoint and some commands to run, and you can connect that, and you have code pipeline kind of invoke those Lambda functions, or you can have it code pipeline reach into like start like a CodeBuild job and have CodeBuild kind of perform those actions that will kick off this traffic generation tool that either runs in Lambda or runs in some place and that just sends a bunch of traffic at your application. So generally, I'd say if you want to do like some of these kind of like, usually for the third-party integrations, it's CodeBuild or Lambda will have like the ability to like invoke this third-party tool via plugin or an SDK or a CLI, and it will invoke the tool and then send that traffic. There's also cases for like performance testing. I've seen some people use like the CodeBuild test feature that like reports on kind of code coverage that also emits some kind of like how long things took. So inside of their test, they'll use like timing functions to say, okay, start the timer, do all this test, like stop the timer, and then like save the output of the timer to the logs or to emit it as an environment variable that I can save later. It's very customizable. Basically, it's like anything you could write in like a bash script or in your test application. And it really does like how that looks depends on the type of application you're testing, how you want to test it, the type of test you want to run. But I would say as a rule of thumb, like the general way that that's done is by inside your code pipeline, you'll have like a code build job that'll be set aside just for doing the test. Or it'll have a Lambda function that calls some API that generates traffic. There is a new CodeBuild feature with these batch builds where you can say, I want to build my application on all of these different architectures, and you just describe that in your build spec, and it will do the same build, run the same like build spec, and run the same tests across maybe different sizes of CodeBuild images or different Docker environments. So how does this perform on on Ubuntu, how does it perform on Alpine Linux or Amazon Linux or Windows, and you can have a timing function or some kind of a performance test inside of your unit test, and then it'll tell you that. So you can kind of, without having to explicitly list everything you want to test, there's a few options in CodeBuild for batch builds, a list, kind of like do all this stuff. Matrix, where it says everything from A, and like the cross product with everything, or the Cartesian product with everything from B, like all the possible combinations. And then there's also like a graph build where you can be more explicit and say, do these builds, then do these, and then once all these are done, then do like these two, and separately do like these four kind of on their own. So because we make it very flexible, like you can kind of do what you need, like whatever you need to do, it's hard to then say like, here is the right way to do it, because the right way is dictated by, like I said, like the architecture of your application and what you're trying to accomplish. I hope that, did that answer the question? I hope that did. I know it was a long-winded answer, but right, cool.
Thanks, Richard. Yes, it did. Thanks.
Cool. If there are no more questions, I'll go on to continuous deployment. I also want to be cognizant of time. I don't want to run over my time and into the next speakers. So for continuous deployment, the goals are to automatically deploy new changes. As soon as a change is ready, we're somewhat confident that it's not going to cause a breaking change. Let's go ahead and deploy it. Let's see what happens. And the idea of this is like, don't just like put it all into production at once and just kind of see what happens. The idea is like start just like a little bit. Put it on just one server, maybe just 1% of my Lambda function, some small amount of my customers. And then I'll watch that very closely for errors. And if there's no errors, I'll do a little more, and I'll slowly expand out. If anyone's ever had like a dog, like dogs do this too, right? They you tell them like, hey, you can't sit on the couch, and they start with like just their paw on the couch, and then when you're not looking, like the other paw comes up on the couch, and then slowly like the first half of their body is on the couch. It's like a very similar thing to that. I apologize. It's probably like, I know like in American culture, like having dogs in the house is very common. I don't know if that's common in Sri Lanka or not, or if I was being rude by implying that, I apologize. So the way this is done, like for like on-premise applications, is CodeDeploy. CodeDeploy automates a lot of this, kind of slowly rolling out an application, observing changes, observing errors if they exist, and slowly or quickly rolling it back depending on your use case. This is kind of what a EC2 deployment CodeDeploy application looks like. So you can say, kind of the files that you want to deploy to the instance, and then it's got these like lifecycle hooks. So you can say, before we start the install, like run this script. So this normally either runs, as this example installs dependencies, or it maybe you want to check like, is this host healthy before I start? Like it wouldn't make much sense for me to start doing a deployment, realize the host is unhealthy, and be like, oh no, I must have broke it, and roll it back when it was kind of unhealthy before we even started. Usually if a host is unhealthy, you just take it out of service anyways, but there's other reasons. Maybe it's performing at some baseline and you want to like check what that baseline is, so after you do deployment, you can see, did the latency get better or worse? Like how did these change? And there's like several of these hooks that are defined in the spec, so you can validate it. It's kind of like a post-deploy action. There's how to start the application once you do the deployment. And this is, I should move sooner. The main parts are like, sending the files, setting permissions on the files, and then these hooks kind of describe like how to actually do the installation and set up this new application. It allows you to set different like deployment options. So you can say one at a time. Let's say you've got 10 EC2 instances. You say, okay, deploy this instance. And once that one's done, deploy another one, and like one after another linearly. Every time one succeeds, start the next one. If one fails, roll them back. You can do half at a time. Or if it's a service that like doesn't have like production users, you're more worried about just moving quickly. Maybe it's an internal service where odds of a fault are very, very low. The risk of a fault is low. The cost of having a failure is very low. Then you can just say, okay, let me just deploy everything at once. If it fails, pull everything back. This allows you to move quickly, but there is a lot of risk in that. And then another option is like you can define deployment groups. So you can say these 6 applications are a group. So you might have a VIP customers. You want them to get changes last after it's been validated from everybody else. So after the entire rest of the fleet has it, we're absolutely certain that this change is safe. Let's go ahead and deploy it to like our VIP customers so they get the most stable experience possible. You can also do the opposite and have like a beta set of customers who've said, yeah, I'm willing to get breaking changes. If it means I get the absolute newest thing right away, I can try new features. I'm resilient to failures. I'm not that worried about it. So you could split this up and you got to move hosts around or set hosts according to like the risk profile of the people who are using specific parts of your application. And this is just a couple of slides specifically on Lambda, like how to do this specifically with Lambda. I'm going to quickly go through these because we're short on time. It's a canary deployment. Canary deployment is where you deploy just a little bit for a while, 10 minutes or so. After about 10 minutes, if there are no errors, you just do everything later. So you might just do just the first 10%. If it works, send in everything else. It's typically called a canary deployment, which is separate from monitoring canaries. These are specifics. CodeDeploy. This is a blue-green deployment. I'll just quickly cover a blue-green deployment is you have your application that's running. It's running on some number of containers. We'll call that the green part of the deployment. And then actually, in this one, it calls it blue. So blue is like what's already running. You spin up a brand new copy of your infrastructure. And then you say, okay, this is identical, but it's like my new application. And then you like either slowly or quickly shift traffic from one to the other. The benefit of this is that if your new application fails for whatever reason, that you can quickly shift back to the other one. You haven't like torn down your old infrastructure, so you can quickly swap back and forth between those. The downside is while a deployment's happening, if you're using something like EC2 instances, you're paying for double the infrastructure during the deployment. So if you can do a deployment quickly, that's great. But if not, like you're paying for double infrastructure. So if you're doing continuous deployment, you may always have 2 copies of your infrastructure if you're doing blue-green. That's why blue-green is better for some of these like container, lightweight, or ephemeral environments. And then this is like specifics, just walking through in the slides how that's done. Because I talk with my hands, it's hard to like do both, like move the slides. I apologize. Continuous deployment goals, so we just covered these goals. And that is continuous deployment. With that, I'm going to close this. Are there any questions? I'm sure there are some. There's at least some. I talk very quickly and I don't explain things very well. So if you have a question, it's because I made a mistake.
I have one question. This is much more opinion-based question. Richard, can you tell us about some of the patterns that you have seen on how to set up the infrastructure when it comes to multi-account setup, how to set the production, how to set the dev environments? What are the best practices that you have seen?
Yeah, definitely. So when I'm setting up an environment, I think the new applications tend to follow like a similar pattern, right? Where it starts with someone as like a proof of concept, like I wonder if I could build this thing. So you've got either it's already in some account that you're using, an AWS account that you're using for something else. It's on your laptop that you're using all your laptop stuff for your development environment, and then like this kind of works, and I'll deploy it, and then it's in some kind of in an environment. But at some point, you'll realize I should probably kind of pull this out of that without doing a full rewrite. I think that and then from there it's okay. Well, I have this AWS account holds this application, which is good for small applications that don't have a lot of users, pretty stable, a few people working on them. But as the application grows, you might want to say, I want to do all of my testing and all of my non-production stuff in a separate account. I'd love to be able to test it somewhere completely separately. And then once I'm confident that change is good, or whatever I'm working on is appropriate, it's not going to break anything, then I'll apply those changes to the environment in my production account. And this allows me to lock down the production account so many fewer things are interacting with it. And CodePipeline supports this with deployment targets. So you can, from CodePipeline and what I generally call a build and tools account, can deploy to target accounts. It goes all the way up to at the, I don't want to say at the extreme end, but what we do inside of Amazon is we say every service that is publicly facing, a tier 1 service, it'll have a separate AWS account for every region that it operates in, as well as for every stage. So let's say I'm making the Richard service, I'm in 4 regions. I might have pre-production and production accounts, separate those two accounts in all 10 regions. So that's like 20 accounts plus some dev and test and some other like one-off accounts on the side. The idea is that like, an account by itself is free. It doesn't cost anything to have an account. And it gives you better what we call like blast radius or impact reduction. If there's an outage or if something happens to that account, if I'm goofing off on Twitch and accidentally show my credentials and that account gets compromised, I haven't like compromised my entire application. I've just compromised that account, which I can quickly shut down and move traffic off of. If I'm using infrastructure as code, I can just deploy my application somewhere else, like via CloudFormation or CDK or some other infrastructure as code tool, and have it spun up somewhere else like very quickly. So there's also this newer, I'd say like the cutting edge of deployment or like multi-account architectures. You see like cellular architectures. So inside of production, instead of just having one production account, I might have 10 or 12, and each holds like a very small version of my application that serves some subset of my customers. So Cole McCarthy has talked about shuffle sharding to assign customers to these cells, and I can just create more AWS accounts and spin up new cells in those accounts. So if something happens to an account, if account hits like some account limit, or there's an outage that's only affecting some specific account, that I can quickly move customers to other accounts to make them more resilient. Now, I don't think that like your average startup starting their first like application, like focusing on a multi-region, multi-stage, cellular architecture would be like a really premature optimization. But it is good to think about like, how would I do that in 6 months or 9 months or a year when I think I'm going to be at the scale that will require that, because some of those decisions you make today will affect how easy that is to do later. I think Colm has frequently said like you should start with 2 accounts because going from 2 accounts to 3 is 100 times easier than going from 1 account to 2. Right? So if you start with 2 accounts, you're already thinking about how do I cross that account boundary? How do I lock down that account boundary so only certain things can cross it? And that informs the decisions that you make about the architecture of your application. If you start with a single account and you don't consider any of that, you could quickly find yourself painted into a corner where it's like, I can't actually separate these 2 because like one of my earlier assumptions just assumed that they would be in the same account. They would have this common access, and now I can't break it up. So like I said, I don't think customers should necessarily start with like this full multi-account, multi-region, like highly resilient service, unless it's something that AWS is able to provide easily, natively, like from the beginning. Let me rephrase that. I don't think customers should spend time thinking about building that themselves. If AWS offers it, it's free, it's a bonus, right? But they shouldn't direct resources towards building it themselves. But they should think about like, how would I do, if this takes off, if I'm super successful, how would I do that? And most likely that starts with, starting with just 1 or 2 accounts. I hope that answers your question.
Yeah, thank you, Raj.
Yeah, I also have a quick question, Richard. So I've been using like Amplify for some time, and from Amplify team as well, they are like releasing Amplify console. So with Amplify console also, you can easily build your application for different environment and so on. And it's really convenient. You can easily hook up CI/CD pipeline. Even it has additional features like you can add custom domains and all that. So I just want to know, is it still using code pipeline behind the scene, or what are your thoughts on like in going forward? Will Amplify console will have more features from code pipeline, like all the customizations and everything that we can do with configuration files and so on? Do you have any insight about it, Richard? Like,
I don't have much insight into what's on the roadmap for the Amplify team, but like I know the people who are on the team, and I know that they are super focused on like what customers are asking for, and it is using code pipeline, CodeBuild, code commit, like under the hood. And this is a pattern I'm seeing more. We see this a lot in enterprises that adopt AWS resources, and this is even the way Amazon, retail adopted AWS or uses AWS. Is that you generally, if you've got 100,000 developers, unless you have a really good, strong multi-account strategy, you don't want 100,000 developers all sharing the same AWS account. So we see a lot of companies building some kind of like tooling, some abstraction on top of the base resources that we provide, right? So you might not be able to go in and like manually set the value for like a Lambda function inside of your enterprise, but you could, you might have some internal tool that allows you to pick one of three values that the company's decided are appropriate for the company. And this is internally, we call this team builder tools. They like build like these abstractions or try to break them down as much as possible. And I feel like Amplify is doing this very well for our customers. So if you don't have a team of engineers building great abstractions for you as like an individual developer, a small shop, you can still rely on like these benefits that Amplify is doing for you, where they're saying, we'll give you CI/CD with a set of kind of like opinionated defaults. Like we think that in general, most people will be happy with this particular setup. And if not, like we give you all the stuff that we use to build it, that you can tweak it yourself. It's open source, so you can make the changes back. And I think that, again, like I don't have any insight into their roadmap, but like if I had to like put money on this, if I had to bet on this, I would say that you're going to see more CI/CD related features and like better exposing and more exposing some of the underlying like DevOps CI/CD features via the Amplify console, simply because like that's what customers are asking for, and that team is like really obsessed with giving customers what they want.